Okay, so good morning, colleagues. I will start with my presentation, which will be part of the topic, because as you can imagine, the ICT and physics education, that's a very broad topic, and we could sit here for a long time. And of course, in many parts, I'm not an expert, so I will talk mainly about the parts I play with my students and we are doing. During my presentation, I bring some practical part. You see this belt, and I will pass those grade, because you know, our attempt is, maybe it's similar in other countries, that we have a revision of curricula, and the main change is to strengthen informatics. But as you can imagine, the number of hours is fixed. So if you give more hours to one subject, you must think where to take off. And of course, physics is one of the good targets. So usually they say it's difficult, the pupils are complaining, so let's reduce physics and let's support informatics. So our attempt is not only about using ICT tools, of course I will do this as well, but also how to bring a piece of physics to informatics, to keep some part for the physics as well. So I will pass those gratings, and you can look on the belt with gratings, and of course, especially when you are sitting farther in the class, then if you are interested at the end, you can come closer, because it's better if you look closer. So you can pass these gratings, because it's about adding colors, in fact, and the gratings enables you to see the color components of this belt. Okay. So thanks for invitation, organizers, and here are some topics. You will see also some resources I have added, because as I said, the topic is relatively broad and I'm not able to cover in deep. And these are the main parts I will speak about. Not much about artificial intelligence, but I can't avoid it. And I guess that in couloirs and discussion we will discuss these phenomena, because I guess we are all exploring, playing with, and trying to find something. So that's the reason. There is a lot of ICT tools you see in the presentation. So in physics we have, for instance, simulations, which are something what we do. Then some microcontrollers based part, when we integrate some informatics with physics, because we can use it for introduction some physics concepts. And of course we can do something with our mobiles. I will try to show something very simple as well here. And of course we can use all those systems like learning management systems and sources of information and so on and so on. I think one very disappointing, at least for me, things with ICT tools is that it's changing very quickly. You can be sure that I am not able to come with 5 years old presentation and to present it and recycle it again, because you would easily find that some parts are completely outdated and not relevant again. And you probably experience the same way, that once you get used to some software, you are satisfied, then after several years it's not developed anymore, you are not able to run it on your computer with new operating system and so on. So this is a little bit disappointing part of it, but I think on the other hand it's a never-ending adventure for us, try to look what is a little bit longer stable and longer used for our educational purposes, and to distinguish effects like just being something new for something which is more relevant and can you serve for a longer time. Of course, that's the challenges. Of course, we are not meaning to replace hands-on experiments, because especially at lower levels like primary education and also secondary education, it's important to have a real experience doing by hand, not only simulations done by experiments. And of course, with those instruments, there is sometimes a danger that we use them like black boxes. That means, well, I just connect, I got some result, and I'm satisfied with this, more or less. So there is no probably sometimes not so strong motivation to look what is behind, what are those principles, because I got some result. And of course, it's a long-time challenge to modernization of the content of physics education, but I think it's valid for all other subjects as well. Okay, the first part we are playing. I didn't brought data loggers because it's probably a little bit more space. And it's not probably so good for low resources places, because data loggers are, at least educational data loggers systems like Vernier and Pascal Nolog, are relatively expensive. If we want to buy, not only for a teacher, that's one place that I, as a teacher, can use it for demonstration. It's quite good because I can project it. But if you plan to do with children, it's of course even more expensive, because you must buy the equipment for, let's say, 10, 15 students at least. So that is, but it is used, and of course it's very quick. We say in Czech Republic, in the community of Vernier users, because I think what is very important, there are a lot of systems, I know at least those three, Vernier, Pascal and Nolog, and it's important to have a community. That's a reason that in the Czech Republic the Vernier is far away most popular, because there is a community of our colleagues and Maths and Physics faculty in Prague who are also resellers for the Czech Republic. So they are doing promoting actions, and they are making community with teachers and collecting the inspiration from the teachers, what can be measured, how to organize laboratory works and so on. So it's really, quite a good community and community support. Of course, it's very quick, and we need, let's say, safe experiments. I mean safe not in the sense like health and safety, but safe in the sense that I, as a teacher, take it and it works. Then I do not spend a half day preparing, and then something just gets out and it's not working, and so my half of day just damaged because no use of it. So safe in the sense that it really works quite quickly. That with data loggers usually works in that way, that you just connect and it's measuring something, so it's really convenient. Then of course you use the same instrument, so usually it's reproducible in one class, in another class, next week, a month later, it's still getting a similar result. And what is very convenient, you can measure more quantities at the same time, and then make relations, which is important. We want to depict some dependence on time, or dependence like voltage on current and so on, if we are studying, for instance, Ohm's law, which is often discussed in the Czech curricular discussion. So these are the advantages. Of course, these are examples and links, and there is a lot of resources. I think in Thursday our colleague Peter Demkanyan will be talk about their work with a coach system, which is another possibility which is quite popular in Slovakia. Okay, these are the examples. Of course, I didn't mention not only just measurements in class, but also we can do some measurements like projects, outdoor projects. Here is measuring current of the water, and of course it enables another thing, measurements who are of the phenomena who are really very fast. So you couldn't notice if I just show you with your eyes, because it's in microseconds or milliseconds. Maybe milliseconds is more relevant with those, and like charging of the capacitor here, and on the other hand, that are very long, so you can start it and let around for a day, two, for a week, and then collect, or for several hours. Of course, you start with pupils, and then you control the result with pupils after some hours, day, or things like that. That is very, very convenient. Of course, it can be done also with microcontrollers. So, of course, there are also some considerations. So I have already mentioned the black box. Then, of course, it's always important to interpret the graphs. Not just I have graphs and we are going out. Just what is it saying, and it's also important, and I hope you know it, or not hope, but I guess you know it, that sometimes if the experiment doesn't come well, you must interpret why it doesn't come well, because you still want to show something. So that's it. And so we should use, as everything we should use intelligently in some way. Again, we can use mobiles. That is something which is quite good. Here is just a typical orientation of axis. And again, there are several applications. In physics, it's quite popular, the Firefox. Physics experiments with mobile, which is run by Aachen University. And of course, it's something which corresponds to bring your own device, which is a strategy. You didn't buy your devices. You can imagine there is for the teacher, there is a problem because it's non-homogeneous. Every mobile is different. For instance, I am jealous for my students when we work on their thesis. They have iPhones and they have pressure sensor. I do not have pressure sensor in my Nokia mobile. On the other hand, they have problems to use light sensor, though it's in it was built in their mobile, but it was blocked by Apple for some reasons. I can use light sensor. So that's the non-homogeneity, and for you as a teacher, it's not very convenient that he has this mobile, she has that mobile, and it's not the same. But some sensors are quite good, and we may ask a question like, what's the magnetic, very simple of course, I didn't bring anything complicated, but the question, how strong is the magnetic field here in Šiauliai? And we can estimate with this here. So another advantage is that it can be connected with a distance measurement. So I will hope it will work. And now you see what is on my mobile. I can take sensor, and to answer the question I did, how strong is the magnetic field? Just to take the total, oh, it was not changed here. Yes, I have to switch here, sorry. So now it's the total magnetic field, and you see it's around 40 microseconds, microtesla, so sorry. So that's quite convenient, and I'm really surprised when I ask in our introductory course at university how strong is magnetic fields of the Earth. Most of the students, I don't know, and everybody can measure. And of course, you know that it's quite good application also for many measurements. It can be used like a sonar measurement, for instance, for making distances and so on. So that is something which is very convenient, but as I said, of course, you always pay something. Just examples, what we did, with our students. So some, what we can say, it can be used if you do not have much resources, but then it's a question if your students have resources for such mobiles. But usually we have accelerometers, gyroscopes, magnetometers, microphones, though we of course must use it carefully because it's usually important the profile, the sound profile of the microphone, which is optimized for the speech, for instance, so for the frequency connected with speech, not for too low or too high frequencies. It might be good for homeworks, for instance, or projects out of school, because the students may do it not bound to some equipment which is provided by school. But of course, there is also the question of equity, because you know the students are sometimes competing about clothes, about equipment, about the instruments they have. and of course this is something we should consider also as well. These are some examples what we did with our students during their thesis work. So you can see magnetic field. Here is gyroscope. You can see the oscillation. That was a disk which was just rotating forward and backward. These are students using like the distance measurement, like echo signals, radar-based or ultrasound-based, not radar, but ultrasound-based measurement of distance. And sometimes they are really at some kind of technical education as well. Because if you are brave, you can say that you do some measurements that may be dangerous for your mobile. So it's better to prepare something that you can make probably oscillation. So mobile is oscillating, and then it's necessary to fix it in something not to fall down and to be spoiled. Of course. I think the most dangerous what we have for the mobile, for this iPhone, was a big yo-yo. It was, I think, this size approximately, and the iPhone was in the middle and was rotating and measuring with the gyroscope the rotation, and you can probably see there's a quite interesting to measure the angles and to show the yo-yo principle for that. That's another feature with the smartphone's measurement compared with data loggers, that usually, if there are no simple question like magnetic field, of course, that's a simple, no other processing, you just see the value. But for those kind of measurements, usually the mathematical working, the math working with the results is more demanding. For instance, if from this angular velocity measurement you want to calculate angle, that's something like a numerical integration behind, which can be done with Excel, but you know, it's not so simple. It must be, well, high secondary or introductory course. But you can see that it's really a tool, and this Firefox is with the physical community quite popular. You may add then for your community, like chemistry, if you use it for something. But I think most of the sensors are some physical base, like gravitometer, accelerator, and so on. Another part we try with some diploma thesis is that you may test something which comes to biology. This is an application called hearing test, and you can measure the sensitive to frequencies, because traditionally in textbook you have that a man should hear the sound with the frequencies from 20 Hz to 20 kHz approximately. I guess the younger colleagues are able to that. I am finishing at 12 kHz, not hearing anything up to that. That's a typical for aging. And here, this application, as you see, you can monitor right and left ear, because it's sending sound, and you are responding to that if you hear it or not. For some frequencies, and there is some approximate levels, which are expectable for your age. And this man, this was a father of the students of mine, was about 50, but you see that his hearing is around 60 years old man. Of course, there is a warning with this application. It's not replacing the doctor or medicine exploration, but it's a kind of warning that if you have this result, you might consider to visiting a doctor. So that's another example, not the Firefox only, but another application. Then another part are microcontrollers, like Arduino here, but of course there is a microbit, which is, I think, very popular in Great Britain, for instance, and supported by BBC, or Raspberry Pi, and probably there are also either. Arduino is popular in our institution because this also used for scientific experiments, so we can consult some problems if we have with our colleagues who use them for experiments. And of course, as I already said, those elements are in agreement with the Czech Republic's educational strategy, which is emphasizing informatics. This is the result. Of course, I choose what I considered the top, but this is the result which was programmed by school students at grade 6 to 9. There was a group. When we tested a series of lessons with Arduino microcontroller. It's unfortunately hidden under this, so the Arduino itself is like this part, like microcontroller controller here, and it was a relatively small group. You can imagine that with the small children you can't work with 30 students, so it was about 16 students in a group, and they were gradually learning like programming and also physics. So this is the example of the belt, which is, I think, visually quite clear. Now you can see the composing balloon. We are reducing green and adding red, so we are getting some the scale between green and red. And now will be adding blue, so we will get blue, and so on. And on the other hand, we are learning with cycles, like 4 cycle in programming, defining and calling DLETs and things like that. So it's a combination of this. Okay, and of course we have a set of working sheets which were leading them through activities, and of course there was a supervisor. So we started with light emitting diodes programming and measuring, done on them. You see that we combine normal measurement with multimeter and measurement with Arduino as well. You can have magnetic sensor and many other sensors like distance sensor, ultra salt and so on. So now we are just working with another student on experiments with ultra sensor, ultrasonic sensor and measuring distances and experiments like that. So that was the sense of the lesson, and each activity was then evaluated by the children. I think I have some examples. Of course, they were gradually well received. There is another activity which can be done with this bell, but preferably in a dark room. You can explain complementary colors and also the notion of shadow and half shadow. Because if you have 3 sources like red, green and blue, which are not at the same place, then if you made some barrier, then in some place you shade blue, in some direction you shade green, in some red, and so the rest colors are combining to the complementary colors like yellow, turquoise and cyan, I think are the English names for that. And of course sometimes we combine with hands-on experiments. Of course that's like a parallel combination of light emitting diodes with a small battery. Another what we can do is that we can draw the circuits in Tinkercad, which can be also, which is used, for instance, by my wife at the grammar school when children are playing with simple circuits like bulbs, resistors, and batteries. So they can build some simple circuit to see whether is it good, whether it really works, because sometimes, you know, if you put light emitting diodes to this battery, there will be no experiment. It will be destroyed immediately with 9-volt battery, because it's not supposed to have a light emitting diode. So you can model this in Tinkercad, which is also used for 3D printing, not only because there is a lot of application, but it can be combined, so it's quite a good tool, and it can be used partly free without no fees. And you can design those circuits as well. And there is another example how we use the Arduino with solar panel. It would be nice to use it today, but you know, weather is not so predictable far away. So it's a long time measurement, 2 days in March, a year ago. And you see that the solar panel was at the place where the sun is shining in the afternoon, because there is no sunshine up to noon, and afternoon we have, this is a clear day, this is what partly cloudy. So we can measure with this, again, longer time measurement, also with Arduino, like with Dataloger. So it may be considered like a partial replacement of data loggers. You can have sensors, but it needs more of your expertise, more of your time to program, to combine. It's not an experiment you just take and go to the classroom to do measurement. So, you know, it's everything. It's cheaper, but it needs more of your input. You pay in another way. And of course, there are simulations and modeling. They are very important for physics. I think from those subjects, compared with biology, for instance, physicists are very popular to use models like, let's have spherical cow in vacuum and then model what we will do. That's the way that we are constraining models and exploring what the models say. Sometimes are more relevant, sometimes are less relevant, but it's a part of our works. My colleagues with his PhD studies explored the effect of PET simulations, which are quite popular and were started by Carl Wieman. I think it's a prominent person in physics education community because he is a Nobel Prize winner. So if you want to cite, but it's an example of career of a physicist who made a Bose-Einstein condensate, who left the career as an experimental physicist, and he is now deeply involved in physics education, and he was the founder of the PET simulations, though he's not involved anymore in this project, but still he's commenting and exploring the education. So what he says, my colleague found that the computer simulations can, in some sense, replace part of hands-on experiments. In sense, if you are talking about learning gains, like making test results. So there is no significant results if you do it, and he did it with hands-on experiments classically, or with simulations exploring the dependencies. The similar conclusion is by Carl Wieman, that if we consider our labs as like justification or strengthening the content which was given on lecture, it's not so effective. But then again, in the test, there are no differences. But what it means, I'm not arguing do not take hands experiments. That means that the labs have a different purpose. They can develop different skills, not just to strengthen the concept which are done during the lessons. So these are some examples. I guess that physicists know PET. It's really very popular website. This is done by great amount of people. They have psychologists, they have programmers, they have physicists in the team. So it's a really good project started by Carl Wieman. In Czech Republic, we have this physics at school, which has been translated in many languages. I'm not sure with Lithuanian, but definitely it's English version and some more. And there's a difference. It was done by one man, one teacher, even secondary school teacher. So it's a really great work. One, of course, maybe it's not so justified by psychologists, but it's still very popular. And of course, you can imagine it was very popular during the COVID pandemic time, because then it was quite difficult to do experiments, and it's also suitable for online courses and so on, if you have them just to put link, and then it's quite intuitive to explore. So these simulations are quite popular. What we are doing, but it's something like higher level secondary school education within, for instance, physics Olympiad. We are doing something like dynamical modeling. The dynamical comes that a typical application is the second law, Newtonian law, that force is mass and acceleration. And in fact, you do this integration like with steps. I think the most intuitive is this Euler method step, that you calculate the acceleration from the force and you calculate velocity in the next short time after, and you calculate the position in next short time after, and then you add time and you are doing the cycle again and again. So a very simple kind of numerical integration. And then
you have to do three integrals.
Yes, and in one dimension, of course, you can have it like in 3 dimensions or 2 dimensions. So it might be even more. There is a lot of tools you can send. Again, I think here is valid that if you depend on some software, it may happen that it won't be possible to use it in 5 or 10 years. I have a colleague who had several study texts about it, and in one it was done by Famulus software, in second Modellus, and now he came, you can predict which is probably the safest way to do this, something like Excel. Spreadsheet. It's because you can be sure that maybe after 10 or 20 years there will be something like Excel still used. It's a little bit more work because you must do maybe many rows if it's long, but it can be done and it's not so a lot of work and it will work. While the other programs, for instance, may not work in some this is the approach. In English there is even the book, Spreadsheet Physics, which is about that. And we have this element even in our textbook on oscillation and waves. And there is an example of mathematical pendulum, because classically the result is made like for small angles and there is no dependence on the original position. But in fact, we all who love swings, we know that the period of the swing depends on how high you go. It differs. So if you take it in a full equation, not just the linear side, it really depends on this. And this is as a supplement to the textbook, so the students who are interested can play. I can give you one more example. Because you may say, well, programming is not for me, it's difficult. And that's one point where I think artificial intelligence is quite efficient. They may be hallucinating in general questions, but if you are asking about programming, it usually is relatively effective. So this is an example of a comet Hale-Bopp, which passed the Sun, the closest approach, in 1st of April 1997. And you can program it, and I asked ChatGPT in April to give me just the code for Python, to make this Euler method I showed, and to do it. We have one advantage, because this comet is included in a Jet Propulsion Laboratory database. First, I'm too lazy to calculate how long is it from the 1st April 1997 to 16th of June for today, how many days it is. But there are tools who can do that, for instance, time and date. So we see that it's 10,303 days from that. You can have it in half of a minute, calculated how long it takes. And then you can compare your I can compare my simulation with the result of Jet Propulsion Laboratory, which for NASA, Jet Propulsion Laboratory is calculating small body positions. You know, the asteroids who may be dangerous for the Earth, so they are calculating the trajectories. And you can find also the parameters. You can see that the period of this comet, which was, I think, star of the 90s, is more than 2,000 years. So unfortunately, nobody of us will see the comet again. But hopefully, there will be some people to see it. And you can view in the NASA system, and please just take this value, 49.672 astronomical units. That should be the distance from the Sun for today. I'm not talking about hours, but it's very far. You can see that the trajectory is really like a prolate ellipse, and there's an angle to the plane of the planets like Earth and to the ecliptic. And now this is the code given by artificial intelligence with some minor adaptation. I think 5 minutes altogether to do if you want. And we have 49.6, and then there is a difference with the. But you know, quite a simple code given by artificial intelligence. So even if you say, well, it's too difficult for me, now we have really a good helper. And of course, there is a just plain projection of the trajectory of the comet given by this code. Okay, maybe just a few mentions. Another tool is GeoGebra, which is a tool for geometry. So it's very efficient for depicting something which has some geometrical meaning or geometrical interpretation. And because, just a few examples, because I guess that you are all looking forward to lunch. This is again example from a thesis. It can be done really graphically. I think nice. This is the example of modeling of a boat with the resistance of water. And of course, it's very convenient that you can share your models with just the link. So in my course, I have for students, I have just links for GeoGebra models, and it works quite well. This is another course, planet motion, but calculated from so-called Kepler equation. So it's an equation that cannot be solved analytically. It must be solved numerically, because it combines the variable in sign and without sign, so you must solve it numerically. And you can see also in this that it follows the Kepler's law, because if I have the same time interval here on the far end of the ellipse, with the same interval you move only a little, so it looks like a continuous. But here in the near end, with the same time interval, the velocity is higher, so you get to farther close, so it's not continuous. You see the points where it gets in the sun interval. So it's really based on this. And of course, you can play, and we did it with our students, for relativity, which is an abstract concept. As we say, it's non-common sense physics, the same like quantum. It's not so intuitive, because we all have intuition about being in car, being in plane, throwing things there and things like that. But we do not have intuition what is it like to move closer to the velocity of the light. So these are abstract concepts, and we must rely more on math and simulations. And this is like depicting two events and calculating the time difference between two events into different inertial frames when we can change velocity. Again, it can be easily shared within your course. There are some resources doing. I think I have found also Boris was playing with GeoGebra, or at least in some context. And maybe another just short point, there are many of simulations for astronomy teaching. We didn't have time to show, but it's not just a question what will be on the sky tonight, but we can say, for instance, how the constellation looked 50,000 years ago, how there are change. How to change the direction of the Earth's axis 5,000 years ago, because for ancient Egyptians, the Polaris was not the North Star. They have Tuban in Draconis because of the precession of the Earth's axis, which changes the direction. This all can be simulated. And of course, just to make an advertisement, you can put probably 7th of September of this year. In Czech Republic, it's about after 8 in the evening, so here it will be an hour earlier. There will be full eclipse of moon. We are not lucky with the eclipses of sun, unfortunately, but if you are keen on it and you are from Europe, next year there will be an extra occasion. So if you like Spain, I think it's time to book your hotel in Spain for the 12th of August 26, because there will be a total eclipse. It will just go between Madrid and Barcelona. So Madrid and Barcelona are outside. You must be somewhere between them to catch the eclipse. Just to remember, a few weeks ago we lost a man who was responsible for decades for calculating the eclipses. For us, he was called Mr. Eclipse, Fred Espenak, who died on the 1st of June this year. And he is author of 5 millennium catalogs of eclipses. You can imagine how many works is behind this. So it can be that. Okay, we could speak about augmented reality, virtual reality, which again usually attract students. We can play with that. We have, even in the Czech Republic, we have a series of books, like Vivid Books, who play with augmented reality. That means that the students, if they have license, may see some extra content, but the school must buy, and of course it needs this investment. They have a lot of promotions, and again, this is a really big team of developers. In fact, they are doing like a fan. There's a company who is doing like virtual walks through Prague, virtual reality, and they are doing it like an extra, like some byproduct, but now quite seriously. They have a teacher, they have some methodical support for that, so even from that point of view, it's really developing. Of course, so I think maybe that is the main conclusion, that really it's important not to go just only on the surface of the computer, but it's always important the content and how you use it. And in the sense, I think it's a never-ending adventure. So I hope also in discussion we may exchange some other ideas. Thank you for your attention.
Thank you, Lukaš. Some questions? Paolo.
No, okay, I have not a question. I have only
Some remarks.
some to add. And there is also the tool mathematics. Do you know? The mathematics is a program which is by far better than GeoGebra. It's a relatively complicated program, but it's fantastic. It can make all the movement of the planets. It can reproduce the movement in the Ptolemaic system, in the Copernican system. It's simply fantastic, and maybe you can check.
Yes, you mean Wolfram Mathematica or
Mathematica?
Mathematica? Yes.
Exactly.
Yes.
Mathematics. It's fantastic. Of course, it's more difficult than GeoGebra, no comparison, but it's simply fantastic.
Yes, even our students have fantastic. They have mobile apps, that if you give them some math tool, they just scan and it gives them the answer. But the problem is that it skips the process of calculating. But it's very popular, I know from my wife. But thank you. Yes, there are many other tools like that.
Mathematica maybe is one of the best, probably.
And most expensive as well.
I know.
Yes, you pay for the power. Yes, of course.
You need to make a deal.
Yes, this is an American company. Mathematica, so,
Only deal. Yeah.
Yes, First of all, congratulations for your very interesting presentation. I just want to add that regarding physical computing, in my department, which is early childhood education department, so as we educate students to become kindergarten teachers or even primary school teachers, we found very useful to use microbit to educate them in physical computing and STEM activities and programming, of course, because it's cheap, has so many capabilities like accelerometer, temperature, light sensors, and so on. But of course, we are not teaching them Python programming or JavaScript. We are using block-based programming, either with Scratch 3, which support it, or with MakeBlock.
I think microbit, I just mentioned it aside, it's very popular in Britain, I think, which is originating in Britain. And I think, yes, for this like primary education or under primary education, this is very suitable. And it can then more or less the similar things like Arduino, of course. So,
and it costs only 20 euros. This is also very important for us.
Good deal. Thank you very much, Lukaš. Every time it's nice to discuss, to listen to you, to speak with you, and
thank you.
Very nice. And here you will find not cold soup, but based on cold soup, new chocolate. Šaltibarščiai chocolate. And this is very, very useful tool, especially for Czech people.
Really? Some beer?
You can open. You can show.
Okay.
Special. Very special.
Must be.
Thank you. Thank you.
We finished approximately on time.
I tried, yes.
Yeah.
You know, it's an advantage to be before lunch because you know that everybody is looking forward to your ad.
Yeah, but you need so inspiring speech. Yeah, motivated speech, you know. It's important.
We will use sensors. Living sensors.
Possible we need some perform some measurement. And
During the yes.
to split into two parts. Some people for lunch and some not.
Oh, great! That's what we were speaking about. You know, I like experiments. So
Sorry,
I just want to show
sorry,
them.
just without content. You need to put content inside.
Yes, it would be difficult to bring this content to my home. You know, the
What
bus
was,
is.
What was the name of the brewery? Gubernia?
Gubernia.
Gubernia must be inside. Yeah.
Yeah. Why not? Auschwitz.